Hello Year 5 and welcome to your last science lesson about space. I mean, how quickly have we gone through this unit? We've just flown through this unit and it's such a shame we haven't been able to do this at school. But to finish it off, we're going to look at what the other planets are in our solar system. Okay, so what we want to do is pause the video and I want you to create like a mind map and think about what we already know about our solar system. So, do you know how many planets there are? Do you think you know what the difference is between a solar system and a galaxy? Which is the biggest and the smallest planet? What order are the planets in? And other than planets, what else is hiding in our solar system? So just pause the video and create yourself a mind map. See if you can have a go at answering those questions. Okay, well, let's go through them then. So a galaxy is a group of millions or possibly even billions of stars, and they're actually held together, okay, in like a massive whirl of gas and dust, and they're held together by gravitational attraction. So you know, with gravity, when we jump, we come back down again. So gravity is surrounding our galaxy, and that we're all pulled in and we're kept in place as to where we are. Now, if we have a look on here, right, somewhere on the end of that little arrow is where we are. Just us, okay, just our solar system, in comparison to those billions and billions of stars within our galaxy. Now, we know that the galaxy that we're in is called the Milky Way, and I'm sure everyone remembers that because we have Galaxy and Milky Way, which are both chocolate bars. Which one you prefer? I don't know, but that tends to be how people remember it. So we're part of our galaxy called the Milky Way. Okay, now we know that the solar system is the set of planets or other objects which orbit a star. Okay, so we know that's what we're part of. Now, the star in our solar system is one of the estimated billions, okay, within our galaxy alone, okay? So, orbiting our star in our solar system, there's four main groups of objects, okay? So, we have planets, okay? We have dwarf planets. We know that Pluto's a dwarf planet because he got kicked off the list. Bye-bye, Pluto. We then have satellites, and then we have comets and asteroids. Okay, now I know that someone mentioned something about asteroids in their work the other day. It might have been Jonas. When we looked at the astronomer's sun and we had that asteroid, that meteorite that came across on the front of our video. So just wanting to think of, just pause the video and have a think, or chat to your partners if you're at school. What's the difference between these objects? Pause the video and have a think. So satellites, okay, orbit planets. So they move around them. Now they can be natural or they can be man-made, okay. Now we know that the moon is one of our natural satellites, okay. We haven't created that moon, okay, it's there. And that obviously orbits our planet. And obviously other planets in the solar system also have their own moons, which we'll come across in a minute. And then we have what we have called our man-made satellites. Okay, now these have been sent up by Earth to be able to orbit planets, and they collect that data and that information, and then they relay it back to Earth. And that's how we find out other information about other planets that at the moment we don't have human life on. Now, dwarf planets are similar to planets, but they haven't conformed to fit the rules of what a planet should be. Okay, now Ceres is the nearest of the three dwarf planets. We've got Ceres, Pluto, and Eris, okay, and they're the three dwarf planets within our solar system. Now, obviously, the most famous one that we know is Pluto, okay. Now, it used to be a planet, but it doesn't meet the third rule, which means it's not large enough to have cleared other large objects nearby, so it's got to be a certain size to be considered as a planet. So in 2006, okay, Neil deGrasse Tyson kicked it off the list, okay, and he demoted it to a dwarf planet in 2006, which Sheldon Cooper from Big Bang was not particularly impressed with. But at that point in time, it just didn't fit the criteria for it being a planet. So it's now been considered to be a dwarf planet. And obviously, dwarf planet, a dwarf, okay, it's like a small mythical creature, okay, so it's very, very small. Now, asteroids and comets, okay, some of the smallest objects we have in our solar system, okay, and they could be anywhere and everywhere, and they come in lots of different shapes and sizes. Now, asteroids are almost small clumps of rock, okay, planet matter, earth matter, space matter. And then we have a comet, which in itself is the same type of matter that could be floating around, but it travels at a different speed, okay? So the asteroid's made up of rocks or metals, and they're all over, okay? And they tend to fill larger areas, okay? So there's actually quite a big gap between Mars and Jupiter. And that has actually attracted lots of these different asteroids. It's actually called an asteroid belt, okay? And the reason why it's a belt is because it's a long strip that runs between the planets of all these asteroids. So almost like wraps around it like a belt would, like around your waist. Now, when an asteroid enters our atmosphere, okay, just like Jonas pointed out, I think, in his English video, this is when it's called a meteor, okay? And this is because outside of our Earth's atmosphere, we have zero gravity, so it floats. The minute we hit our atmosphere and you penetrate into the Earth's atmosphere, you come from being in zero gravity to being a gravitational pull. And obviously, we're all pulled to stand flat on our Earth. So you imagine coming from floating, you've come into our solar system, you've then come into our Earth's atmosphere. By laws of gravity that we have on this planet, you're then going to be pulled towards the Earth, okay? So it picks up that speed. And as it picks up that speed, it burns, okay, from the sheer speed as it travels through. And on very rare occasions, they actually can get all the way through to the Earth's centre, okay? And they will crash into the Earth's surface. And these are called meteorites, okay? Now, comets are slightly different because they're actually made up of ice and frozen gases like carbon dioxide, which is obviously what we breathe out and is expelled into our atmosphere. Now, they're sometimes referred to as icy dirt balls. You can go, well, why are they icy dirt balls? Well, obviously, they're like balls of dirt and rock that have been frozen up, okay? And they orbit the sun, but most of them don't come near Earth. Okay, now what you can see here is this is the nucleus. It's a bit like what you learn in science when you look at cells. You always have like that core little bit in the middle, which is called the nucleus, almost the eye of the cell. And the nucleus here, which is the main part of our comet, is that frozen ice and gas that's been blocked up. The extra bit that's coming out from behind it, which is the tail, is actually made up of the gas and the dust. Okay, now as they pass nearer the sun, that heat and radiation means that the comet actually gives off that dust and gas, obviously, because it creates almost like a temperature change. Now, obviously, that's what gets that tail. So that's obviously what we look at when we see like shooting stars. Okay, and it is because that gas has been heated up from the sun and almost propels it, and that's what you can see trailing behind it. And the reason why we call it a tail is because that's what it looks like. It follows, doesn't it, the nucleus? Now, the most famous comet that we've ever seen, and you might study this in one of your subjects, one of your history subjects in secondary school, is called Halley's Comet. Okay, now it's a very, very famous comet that we can see from Earth every 75 to 76 years. And there's a very famous tapestry called the Bayeux Tapestry. And at the time that it was created was when they had actually seen the Halley's Comet, and it was actually stitched into the tapestry. So if you ever get to go and see that, it's fascinating. But that's a comet that comes around every 75 to 76 years. It's actually a recurring one that we see more often than not. Now, planets are obviously the largest part of our solar system, okay, excluding the sun though. We know the sun's the biggest one. And there are actually 8 planets in our solar system. Now, going back to when we said that Pluto was kicked off the planet list of being a dwarf planet, it didn't conform, so it didn't fit with the rules that are specified to be a planet. So here are the rules. It must orbit around the sun. It needs to be roughly spherical. We know spherical means round, like a sphere. And it needs to be big enough to have cleared other objects of a similar size. For example, satellites. It needs to be able to go past them. Okay. Now, obviously, that's one of the reasons why Pluto wasn't accepted, because it wasn't able to clear other objects that were of a similar size to it. So those are the 3 rules for it to be confirmed, okay, to be a planet. Now, there are 3 main types of planet in our solar system. Okay, so bear with. So we've got terrestrial planets, okay. Now, these are planets that tend to be made up more of rock and metal, okay. So we've got planets like Mercury, Venus, Earth, and Mars. So we, including those of the 3 planets, are terrestrial planets, okay. So we're made up of solid materials. But then you have the gas giant planets. Now, I'm sure you can assume from the title gas planets that they tend to be planets that are much bigger because they're made up of other gases. And it tends to be things like hydrogen and helium. Now, we know when we fill up balloons with helium, they expand. And obviously, that's why these planets are bigger, because of the gases they're made up of. Now, the 2 planets within our solar system that are gas planets are Jupiter and Saturn. And then we have our ice giants. Now, I'm sure you can think, well, if they're going to be giant, they're going to be big planets. And it says they're ice giants. So these are most likely going to be planets that are going to have atmospheres at very cold temperatures and be elements of ice. Now, Uranus and Neptune have atmospheres of mainly hydrogen and helium, which are both gases, just like our gas planets, but their interior, so the inside of the planets, is actually made up of ice. So although they are also gas planets, those gases are kept very, very cold because the core part of that planet is made up of ice. So you've got terrestrial planets like us that's made up of rock and metal. You then have your gas planets that are made up of hydrogen and helium. And then your ice planets, which are also made up of hydrogen and helium, but have a frozen interior. Now, here's a challenge for you. Pause video. Can you name these planets in order? And I'll give you a clue. We start with the sun, and you can clearly see that we're the Earth over here. You can see that these are going to be our gas planets and these are going to be our ice planets. So pause the video. Can you name them all in order? Off you go. Okay, so the planets in order go as follows. We have the Sun, then we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now, we've done a little bit of this before where we've looked at mnemonics. And mnemonics is what we look at in English. So we've got I saw a wubbub. Okay, I saw a wubbub is a mnemonic because each letter at the beginning of I saw a wubbub, each one of those letters, okay, symbolizes or starts with one of our conjunctions. So, one of the ones that I used to know was many vile earthlings munch jam sandwiches under newspaper piles. Now, I can't have newspaper piles anymore because poor Pluto got flicked off the list, okay, so he's gone. So I remember it as many vile earthlings munch jam sandwiches under newspapers, okay. Now, let's see if there are some other ones. So, one of the other ones here that somebody has created is my very educated mother just served us nachos. And there are lots on there that you can think of. I know there's a one that goes along the lines of my very easy method, just something us something. I can't remember what that one is now off the top of my head. Oh my goodness, it's completely gone. But a mnemonic is where we create like a phrase or a saying where each letter at the beginning of the word starts with the same letter of what it is you're trying to remember in order. So I have sent home some slips for you to have a go at. What I want you to do is pause the video. I've sent you home 3, but if you want to come up with 1, that's fine. And I want you to try and create a mnemonic, so a sentence structure of words that's going to help you remember the order of the planets. Okay, so pause the video here so you can see this example. See if you can have a go at creating your own. Okay, so as these planets orbit the sun, the different planets take different lengths of time to complete. Okay, now the time it takes the planet to orbit the sun is called a year. Now, other planets have a larger orbit than Earth do. So obviously for us it takes a year. It takes us 365 days and a quarter to be able to get all the way around. But obviously there are planets in our solar system that are a lot bigger, which means that they travel a further distance or potentially travel at a different speed. So this means that a year on our planet is going to be different for other planets. So how long is an Earth year? Okay, so we know it's 365 days, okay? Now, a year on Mercury takes the same amount of time as 88 Earth days. So we do it in 365 days and a quarter. Mercury does it in 88 Earth days. So how long it would take us to get 88 days through our year. Now, it's got a small orbit length, but it travels a lot faster. So it completes that orbit quicker. Now, it actually completes it 4 times faster than we do. So in the time it takes us to do it in 12 months, effectively, Mercury does it in 4 months, roughly, okay? Now, the planets take different amounts of time to complete one rotation on their axis. Remember, we had that axis almost like that 14, 15 degree angle. Now, some planets like Venus, they will actually rotate very slowly, okay? So their day actually lasts longer than their year does. So 1 year, so that turn that goes all the way around the sun on Venus, takes 225 Earth days. 1 day on its axis on Venus takes 243 Earth days. So imagine Venus, it goes all the way around the sun in 225 days, just like we would do in 365 days. We turn on our axis in 24 hours, hence why we have the 24-hour clock. Venus doesn't though. Venus takes 243 days to do a full 360-degree turn on itself. Now, it's also the only planet that actually does it in a clockwise direction. So we rotate anti-clockwise. Venus actually does it anti-clockwise. So now that I've blown your brains a little bit with all that exciting information, you've got an end of unit quiz to do. So you've been sent the quiz home and all you need to do is select the correct answers. Okay, so you might want to go back and have a look at some of the videos you might have got stuck on, or go back and have a look at some of the work that you've completed in your books, because that will all link to the learning that you've done anyway. Okay, so that's the end of the video. I want you to go and have a go at doing that end of unit quiz, and then after half term we're going to start a new topic. Okay, so I hope you've enjoyed this topic. I apologise we haven't been able to do this at school. It would have been much better doing this at school. It would have been so many different things we could have made during our art lessons and science lessons. But alas, that hasn't happened, so I do apologise. But have a go at your end of unit quiz and see how you get on, and then we'll start our new topic after half term. Okay, good luck to you, Year 5.